Hello future engineers, subscribers, viewers, and students. Here is another video in dynamics, particularly kinematics of particles. So I hope that through this video, your skills in analyzing problems in dynamics will be enhanced and improved. So you must go back to the first part, the lecture part, so that you'll be able to anticipate the challenges ahead of the problems in dynamics. So here is the problem. The motion of a particle is defined by the relation x equals 2t cubed minus 9t squared plus 12t plus 10, where x and t are expressed in meters and in seconds respectively. So determine the time, the position, and the acceleration of the particle when the velocity is 0. So in particular, this velocity is also v sub x, the x component of velocity, if we treat this as motion of the particle along straight line, which is along x. And velocity is simply the derivative of x with respect to time, or dx dt. So v equals v sub x equals dx dt, and it is equal to 6t squared minus 9t minus 18t plus 12. Then since requirement is to find the time when the velocity is 0, and we also need to compute for the position, which is just the value of x for these times. So in this expression for velocity, or v sub x, 6 is common, so dividing everything by 6, so v equals v sub x equals t squared minus 3t plus 2 equals 0. Then we factor this into quantity t minus 1 and t minus 2, or you may use your calculator there, equals 0. So that means there are two periods of time, specific times, where the velocity is 0, or where the velocity of this particle is 0, and that is when t is 1 second and t is 2 seconds. Then when t is 1 second, we compute for the position, and that is we simply substitute t equals 1 into this equation here. So x1 is for t equals 1 second, so x1 equals 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 plus 10, and that is 2 minus 9, negative 7 plus 12, 5 plus 10, so it is 15 meters. So the particle is at rest when it is 15 meters to the right of the origin. So again, substituting, x is 2 times 1 cubed minus 9 times 1 squared plus 12 times 1 plus 10. So solving for x sub 1 is equal to 15 meters. Then for the acceleration, we have to derive the expression for acceleration. That acceleration is simply the derivative of velocity, this expression here, with respect to time. So acceleration is also a sub x equals derivative of v with respect to time, or derivative of v sub x with respect to time. This is already the expression for the velocity. So the derivative of velocity with respect to time is 12t minus 18. So that's the expression for acceleration. So acceleration equals ax equals derivative of v with respect to x equals 12t minus 18. Then when t is 1 second, we have 12 times 1 minus 18. So the acceleration is 12 minus 18, and that is negative 6. So a sub 1 when t is 1, or ax1, is 12 times 1 minus 18. So a sub 1 equals negative 6 meters per second square. So that means one set of answers would be when for t equals 1 second, the position is 15 meters and the acceleration is negative 6 meters per second square. So that's the first answer. So when v is 0, t1 equals 1 second, x sub 1 equals 15 meters, and ax1 or a1 equals negative 6 meters per second square. We now proceed to the second situation where t is 2 seconds or t sub 2 is 2 seconds. So for t equals 2 seconds, the velocity is also 0. So the position is x sub 2, substitute here, 2 times 2 cubed minus 9 times 2 square plus 12 times 2 plus 10. 2 times 2 cubed is 16 minus 9 times 2 square, negative 36. So 16 minus 36 is negative 20 plus 12 times 2, 24. 24 minus 24 plus 10 equals 14. So position when t is 2, the particle is also at rest. So x sub 2 is 2 times 2 cubed minus 9 times 2 square plus 12 times 2 plus 10. So x sub 2 is equal to 14 meters in my calculations. Then the accelerations, we already have expression for acceleration, which is from acceleration, which is 12t minus 18. So all we have to do is substitute t equals 2 seconds. So a sub 2 or ax2 is equal to 12 times 2 minus 18, and 12 times 2 is 24 minus 18. That's positive 6 meters per second square. So a sub 2 or a2x equals positive 6 meters per second square. So the second set of answers for this problem would be the particle is at rest, velocity is 0, t sub 2 is 2 seconds, x sub 2 is 14 meters, and the acceleration a sub 2 or a sub 2x is 6 meters per second square. So t sub 2 equals 2 seconds, x sub 2 equals 14 meters, and ax2 equals 6 meters per second square. So that's it for this video. I hope that you were able to follow the explanations and the solutions, and hoping for your presence in viewing the next videos to be uploaded here in YouTube, in my YouTube channel.